Let's start by talking through the names of the parts of a circle. The length around a circle is called a circumference. A line from the circumference to the centre is a radius, and if the line carries on across the circle, it becomes a diameter. If the diameter does not go through the centre, it is a chord. The chord creates two areas within the circle, the major segment, the big one, and the minor segment, the small one. A bit of the circumference is called an arc. The area created by two radii, like a slice of pizza, is called a sector. The big sector is called the major sector, and the smaller one is called the minor sector. A straight line that skims the outside of a circle at one point is called a tangent. The circumference of a circle is the distance around it. For almost every other shape, we would call it the perimeter, but circles obviously have a better marketing team than the other shapes. To find the circumference, there are two formulae. Well, actually there's just one, but depending on what the question gives you, it may be helpful to remember two. If you're given a diameter, such as 10 centimeters, to find the circumference, we simply multiply the diameter by pi. What is pi? Pi is simply a number. Sadly, the number goes on forever, so we always have to round it. It's roughly 3.14 though. When we times the 10 by pi, we can write the answer as 10 pi, just like we do in algebra. This is called writing a number in terms of pi. If we want to find out the answer as a number, we would use a calculator or multiply the 10 by 3.14, and we find the answer to be 31.4 centimeters to one decimal place. If we're given a radius of 20 centimeters, our formula no longer works since it needs a diameter, not a radius. A diameter is always twice the size of a radius. If the radius is 20 centimeters, the diameter will be 40 centimeters. So the circumference will be 40 pi or 126 centimeters to three significant figures. Circles aren't always whole, and we could be given a semicircle with a diameter of 4 centimeters. The process here is very similar, but all we need to remember is to halve the answer. We are no longer finding the circumference though, since the circumference must be the full distance around a circle. We are now finding the arc length, since an arc is a bit of a circumference. We will times the 4 by pi, but we also must halve it. That will give us 2 pi or 6.28 centimeters to three significant figures. We can now get a bit more adventurous and find the total perimeter of the semicircle. We already know the length of the curved bit, so we only need to add on the diameter to complete the perimeter. 6.28 plus 4 is 10.28 centimeters, again to three significant figures. When we're working with quarter circles, we are likely to be given the radius. If the radius is 3 centimeters, we must first double this to find the diameter of 6 centimeters. We can then times this by pi to find the total circumference of 6 pi, but we need to divide this by 4 because we have a quarter circle. This will give us 1.5 pi or 4.71 centimeters to do decimal places. The perimeter will once again require us to add on the missing bits. The quarter circle has two radii to add onto the arc we've already worked out. 4.71 plus 3 will give us the perimeter of 10.71 centimeters to do decimal places. The area of a circle also has a nice simple formula. This time we need to have a radius, not a diameter. To find an area, we square the radius, then times it by pi. If the radius of a circle is 5 centimeters, we will square it to make 25, then times it by pi, giving us 25 pi or 78.5 centimeters squared to three significant figures. If we are only given a diameter of 8 centimeters, then we need to halve it first to give us 4 centimeters, then square it to make 16 and times it by pi, giving us 16 pi or 50.3 centimeters squared to three significant figures. If the diameter of a semicircle is 6 centimeters, we will first of all need to find the radius by halving the diameter. We will square the radius, the 3, to make 9 and times it by pi to give us 9 pi. We have half a circle, so we'll then need to divide this by 2 to give the answer of 4.5 pi or 14.1 centimeters squared to three significant figures. If we have the radius of a quarter circle, and say it's 8 centimeters, we can use the formula to find the total area of the full circle. Square the 8 to give us 64, then times it by pi to give us 64 pi. We have a quarter of a circle, so we will need to divide this by 4 to make 16 pi or 50.3 centimeters squared to three significant figures. We have found the area of a full circle, a half circle and a quarter circle, but it is quite simple to find the area of a circle that has any angle. To do this, we need to find two things: the area of the circle and the fraction of the circle we have. If we have a sector with angle 110 degrees and a radius of 10 meters, we can start by finding the fraction of the circle we have. All circles add up to 360 degrees, and we have 110 degrees. So we can divide 110 by 360, giving us 0.305 recurring. Or we can just leave it as a fraction. To find the area of the full circle, we can square the radius to give us 100 and times it by pi to give us 100 pi. We can then times the fraction of the circle we have by the area of the full circle. 110 over 360 times 100 pi, which will give us 275 over 9 pi, or 96.0 meters squared to three significant figures. We can also find the length of the arc on the sector with angle 110 degrees and a radius of 10 meters. The process is the same. Find the angle and times it by, this time, the full circumference. The angle is 110 over 360, the circumference is 20 pi. The arc length will therefore be 110 over 360 times 20 pi, giving us 55 over 9 pi, or 19.2 meters to three significant figures. We can finish this topic with a bit of fun. If we know the sector area is 40 pi and the radius is 20 centimeters, we can find the sector angle. Always start by writing the formula, then filling in the bits you know. Sector area equals angle over 360 times pi times r squared. 40 pi equals x over 360 times pi times 20 squared. We can divide the pi both sides to get rid of them. We can also divide the 20 squared, or 400, giving us 0.1 equals x over 360, times both sides by the 360 to give us x equals 36.